Today's lesson, we want to be able to evaluate and compose functions. So let's do a quick warm-up on evaluation. So it says let y equals 3x plus 2, and you want to evaluate the equation when x equals 2, and we also want to evaluate the equation when y equals negative 7. So let me give you a minute to try both of those, and we'll check your results. So when we're evaluating, remember we're taking the value for the variable given and substituting it into the expression or the equation. So in this case, we have the equation. So if x equals 2, we're going to substitute it in place of x here and then follow our order of operations accordingly. So that means we have to do 3 times 2 and then add 2 to that. Well, we know 3 times 2 is 6 and 6 plus 2 is 8. So when x equals 2, y would be 8. So for our second part, it said evaluate the equation when y equals negative 7. So again, we're going to substitute negative 7 in for y. So that means we would have negative 7 equals 3x plus 2. And so we could figure out the value for x now. So to undo the addition, we would subtract 2 from each side. So that means we would have a negative 9 equals 3x. And again, to undo the multiplication, we do division, and then x would equal negative 3. So again, when y is equal to negative 7, we have x being equal to negative 3. So we were doing some evaluations of functions, and we were talking about in our previous lesson what makes a function, what doesn't make a function. And so when we're working with functions where one input has one specific output, there's a couple of things to remember. Function notation, right? So instead of writing an equation using variables like y equals 2x plus 5, we can use function notation and write it as f of x equals 2x plus 5, right? So f of x says the value of the function of f at x. All right, so I've been referring to it f of x. So the function is the rule, right? And x would be the value that we're going to put into the rule, right? So f of x is representing y, or y equals, and they're meaning the same thing. So we're saying, okay, what output would happen if you're given an input? Function notation can use any letters. We could have g of x, h of x, j of x, f of x. We typically don't use a function name of like y and x because those represent the inputs and outputs, but again, any other letter would suffice. So let's see, how can we read function notation? So here we have the function, the rule. The rule is 2 times x plus 8, and the function's name is f. So f of x equals 2x plus 8. So how do we read this? F of 5. Well, the function rule f, which is this, evaluating it when x equals 5. So we're going to substitute 5 into x for the rule, our function, and evaluate it. So f of 5 equals 2 times 5 plus 8. Well, 2 times 5 is 10. 10 plus 8 is 18. So f of 5 equals 18. So when the input is 5, the output is 18. Okay, so let's try another one. Here we have f of x equals 2x plus 8 still. Now it says f of x equals 6. Well, how do we read this? F is our function, this is our rule, x is the input, 6 is the output. So it's saying what input for the function gives us an output of 6. So we're going to take that output and put it here in our rule, right? So if the output is 6, what input makes that happen? So we're going to undo that rule to find out. So to undo the addition, we would do the subtraction. To undo the multiplication, we would do the division. And it says x equals negative 1. So the input of negative 1 gave us the output of 6. So we could say f of negative 1 equals 6. This input for our function gives us this output. So that's one way we could talk about function notation and evaluating functions, whether we're given an input or an output. We also could take a look at it in a table format. that we talked about before. So here is our rule, our function f of x equals negative 3x minus 5. So we've got x, our inputs in a table, and y, or f of x, as our outputs in our table. So how do we read this? No, here, f of 10/3 is saying for our function f, right? If our input is 10/3, what is the output for the function? So remember, inputs are x's, right? Here is our input for our table. So here's our inputs. These are the outputs. So the input of 10/3, that's here, right? So if the input is 10/3, what output goes with it? Negative 15. All right. Now, f of negative 17. What does that mean? Negative 17 is the input. What output goes with it? Well, if this is the input, we're going to look at our input column, find negative 17. What output goes with it? 46. So f of negative 17 equals 46. All right, let's have you try the next one. Let's see, what do we think this is asking us? F of x equals negative 9.2. Well, x is the input, and that's unknown. So can we find the input that gives us an output of negative 9.2? Sure, if we go to our table and we look at the output column, and we go down to see, well, where is negative 9.2? What input goes with it? 1.4. So x has to equal 1.4. So we put that here. All right, let's have you try the next one. F of x equals negative 17. X equals what? Since negative 17 is the output, what input goes with it? 4. So we have x equals 4. All right, we've got a couple more here. F of 4 plus f of 0. Do you know what it should equal? Well, we have two evaluations to do. First, we have to evaluate f of 4. So if I have an input of 4, what output goes with it? Negative 17. So let's just jot that down here. F of 4 is equal to negative 17. Then I have to evaluate this one. F of 0, well, that's equal to negative 5. Well, what am I supposed to do with these two evaluations? We're supposed to add them together. Well, negative 17 and negative 5, that gives me a total of negative 22. How about the next one? We've got f of negative 5/3 times f of 1.4. Do you know what it would be equal to? F of negative 5/3 is equal to 0. Here's our input, there's its output. F of 1.4 is equal to negative 9.2. So we have 0 and negative 9.2. What are we supposed to do with them? Multiply them together. Well, 0 times anything is always equal to 0. So that's how we can evaluate functions using our table. looking at the inputs and outputs based on what we're given. So if we're given an input, can we evaluate it to find the output? And then sometimes we may have to extend upon it to do an operation to get our result. Or if we're given an output, can you find the input that goes with it to get that result? So we can go both ways. Given an input, find the output, output the input, and then any operations that may follow. Now we said before, a table just represents points on a graph. It's another way of representing it. So here we have this graph, and we want to do some evaluations of this function, f again. So let's see. We want to know f of 9. 9 represents the input. What output goes with it? Well, the input of 9, that's an x value. And here's, remember, our inputs. And so here is 9. What output goes with it? So I got to go up to the function, say, oh, here's the output. That's at 6. So f of 9 is equal to 6. We need to evaluate now f of 0. If 0 is my input, remember inputs are x's, what output goes with it? 3. Now we have f of x equals 4. We need to find x. X is the input, 4 is the output. So this time I know the output, and the outputs are y. So I'm going to go to where the output is 4. And now I have to see, well, where is that on my function? So I have to go over to my function, say, oh, here's where I have the output of 4. What input does that happen at? 3. So remember, x equals 3. So f of 3 gives us 4. All right, let's see if we can try these two, and then we'll check. F of x equals 5. That means the output is 5. Well, 5 is the output. The input that happens is at 6. For our next one, f of 3. My input is 3. The output that happens there is 4. F of negative 6. My input is negative 6. The output that happens there is 1. I'm supposed to add them together. 4 plus 1 is 5. So again, we can evaluate the function graphically by locating the inputs on the x-axis and their corresponding outputs on the y-axis, and vice versa. If we're given an output, we can find its input and then do any other evaluations or operations to that. All right, for our next scenario, here we says, for g of x equals negative 2x plus 1, find the following. So can we evaluate the function based on these givens? Let's give you a minute to try to work on the first 3, and then we're going to check. Our first one, g of 2, that means if we have an input of 2, what output will result? So I'm going to put 2 in place of x and see what happens. I'll have 2 times negative 2, but it will be negative 4, plus 1, that would give me negative 3. So g of 2 equals negative 3. Similarly, we're going to do the same thing for g of negative 7.5. That's our input, which we'll put here to evaluate. Well, a negative times a negative will be a positive. 2 times 7.5, that's 15. And then I'll add 1. 15 and 1 is 16. So g of negative 7.5 is equal to 16. For our third one, it said that g of x equaled 7. So this is the output. We're going to substitute that here for our function. So 7 equals negative 2x plus 1. And we're going to have to undo that to solve for x. So we would have to undo the addition by subtraction, undo the multiplication by division, and again, a positive divided by a negative is going to be a negative, so x equals negative 3. All right, now there's a couple more we want to try. So again, here's our function, g of x equals negative 2x plus 1. Can you find g of 13 divided by g of 3? So for that one, we have to evaluate the function twice. We're going to substitute 13 in for x and 3 in for x and see what results. So we're going to have in our numerator a negative 27 and our denominator, I'm sorry, a negative 25, right? Because we had a positive 1 there, my mistake. And then we have a negative 5 in our denominator. So we have a negative 25 negative fifths. Well, a negative divided by a negative is a positive, and 25 divided by 5, that's 5. So g of 13 divided by g of 3 is equal to 5. So we've worked with our function notation and composing our functions, evaluating our functions, whether it's in a table, a graph, or just the rule given to us here. And now we're going to do some more practice with those items.